My name's Chris. I'm going to be talking about my CSC project today. So the title of it is DATAWorks. So what this program is designed to do is to be able to create dose response curves and determine statistical significance between dose response curves for two different treatments with multiple inputs for those treatments. The reason why this is important and why this is useful is this is what I have to find for the research lab that I'm a part of. And this is something that I was having to do in Excel by hand, and it was taking me like 30 minutes in order to just get through one data set, and it was very strenuous. There's a lot of room for human error in it, and I wanted to be able to remove that. So here is the start of my example code. Anything that the user needs to input is going to be in the first three sections, and all of them have user input defined for it. So it starts out with the user puts all of their drugs or all of their file names for treatment 1 in this first section. So file name drug 1 would go here, file name drug 2 would go here. All of these need to be in .xlsx files. They then move on to this section for treatment 2. And then section 3 is where it talks about if you took multiple measurements at one point, it would then be able to average all of those and just have it be one output instead of multiple ones. So we kind of come down and move into the next section of where the code really starts to work, and this is just creating a matrix, so it's importing all of the files using XLSRead and then consolidating them down into one more easily used file. So the data for the set when it's in the XLS file is organized like this. The reason behind it is the program that I use is ImageJ, and ImageJ gives you outputs like this. So if it's not already structured like this, you need to have it be where there's one column of information that doesn't matter, and then your second column is the information that you care about. This runs through and it gets rid of the first column, so only the second column is taken, and it consolidates all of them down into one data set. This next section comes in and dealing with K, so that was the user input of how many data points were taken at each measurement, and is just averaging those. So if I took 3 data points, it's then taking the first 3 values and then averaging them, and then taking the next 3 and so forth and whatnot until it reaches the end of the data set. Sections 6 and 7 are important because these are the two conditions that need to be met in order for analysis of variance to be carried out, which is something that is taken care of later on in the code. If these conditions are failed, the code is still going to run. It's just going to output them as, I believe, a 0 for this and a 0 for that, showing that it wasn't met, and then it's on the user to then go and fix those. This is where the dose response curve is actually created. So it's finding the standard error for those using the built-in standard deviation, and then a equation that I found online. And then we move on to section 9 through section 13, which are the exact same thing, except it's for your treatment 2 or for your second drug, depending on what you're measuring. And the reason why I don't have a while loop consolidating all of this is because I felt that it was easier for someone else to come in and follow it, and be able to have them be able to have greater control over the outputs, and when they're editing it, to be able to have more of a logical output instead of just having to click through a function file and try to understand what that's doing. We then move on to section 14, which then takes all of your data from all of your data from treatment 1 and puts it in odd columns, and all of your data from treatment 2 and puts it in even columns. And then it comes and it does a analysis of variance to be able to get the p-values comparing column 1, column 2, column 3, column 4, etc. And then section 15 comes and takes all of the data, consolidates into a bar graph with standard error and statistical significance. So I'm going to take through a run of what it would look like. I've already typed in most of them, but you'd have to output it, and there it is, .xls file. Come down, I use 3 for all of these. So then run the code, and the code takes a little while to run. It is a larger file. So these figures that are popping up and then disappearing, that's because any time that analysis of variance is run, it outputs a table and a figure, and that's not really necessary for the user, so those are just being closed as soon as they're created. And then at the end here, we have our nice little bar graph, which has your dose response curve 1, dose response curve 2, standard errors. There's your dose response curve for 2, there's your dose response curve for 1. And then if there had been statistical significance, you would have seen a little asterisk sign. If we come here towards the bottom, we also have our p-values and if it passes the normality test. Thanks for watching, and that's my project for this year.